Okay, now we're going to talk about negative exponents and base numbers that are raised to the zero power. So with negative exponents, you need to change a negative exponent to a positive exponent. You cannot operate with negative exponents. So like the previous video when I had 4 to the second power, 4 to the second power is 4 times 4, which is equal to 16. If I said 4 to the negative 2 power, that's not going to be negative 16 or negative 8. We need to change that so that it's no longer a negative exponent, it's a positive exponent. We can only operate with positive exponents. So how do we do that? You take the reciprocal of the base and change the exponent to a positive value. All right, for example, we have 3 to the negative 2 power. 3 to the negative 2 power cannot be solved. It is not negative 9. It is not negative 6. You cannot operate with that negative exponent. So let's remember that it's automatically over 1. A whole number can be made into a fraction by placing it over 1. So we know what the reciprocal of that is going to be is when we flip the numerator and the denominator. So I'm going to flip that, and now I'm going to have 1 over 3, and since I made that into its reciprocal, that negative 2 becomes a positive 2. So now this is going to be 1 over 9. If I have 1 over 7 to the negative 2 power, now 1 over 7 to the negative 2, 1 over 7 is a fraction. How do I make that into its reciprocal? I flip it. And that negative exponent now becomes a positive exponent. And that's going to equal 49. So I'm evaluating these exponents. All right, or putting them in standard form. Now what if I had 2/3 to the negative 4th power? Okay, so I have a fraction. I have negative 2/3. How do I get the reciprocal of that fraction? I would flip it first. So now that's going to become 3 over 2. I flipped the fraction to its reciprocal. I'm still keeping those parentheses around there because the whole fraction has to be multiplied by itself 4 times. So once I flip that numerator and denominator to its reciprocal, it becomes a positive 4. That is going to now be 3 to the 4th power and 2 to the 4th power. So that's going to give me 81 over 16. Okay, now this last example for this is really important. If I have negative 6 is raised to the negative 3rd power. Okay, well, I need to make it a fraction because I'm going to be flipping it to its reciprocal. So I'm going to put that over 1. So when I flip that, I have my 1 as the numerator and my negative 6 stays in parentheses. The only thing that changes to a positive number is that exponent. So the negative 6 is the base, and the base does not change to a positive number when you put it into its reciprocal. The base always stays the same. So the only thing that's changing to a positive is the exponent. So the exponent is only changed to positive, not the base. Okay, not the base. Okay, that's how we work with negative exponents. Let's talk a little bit about the zero power. Now, every year when we introduce this, I will say to my students, what do you think 2 to the 0 power is going to be? And I would say 99.9% of my students will say 0. Because what are they doing? They're taking the base and they are multiplying that base by 0, the exponent. Now at this point we know that you do not do that. You are not going to be multiplying the base by the exponent. It's how many times the base is multiplied is represented by that power. So what I'd like you to do, I'm going to prove to you why this works. I'd like you to write 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0 power. I'd like you to write those down for me. I'll give you a quick second, or you can pause the video. And then I want you to give me the standard form for that exponent. So 2 to the 5th power is 32. 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 to the 2nd power is 4. Now, 2 to the 1st power. We've talked a lot about ones that are automatically understood. We just talked about that with a whole number. I can take a whole number and put it over 1 and it becomes a fraction. We know that. We know that 1 can be a denominator and make a fraction for a whole number. We also learned solving equations that we would put a 1 in front of a variable so that we automatically understood that there was a 1 there. This is the same thing. Every single number that you know, -5, 100, -1000, they all have an exponent of 1. That means that you are multiplying the number itself only one time. So that leaves you with the same exact number. Now at this point, like I said, everybody thinks 2 to the 0 power equals 0. And that is not correct. I want you to look for a pattern for me. 32, 16, 8, 4, and 2. As I'm coming down, I'm losing a 2, right? 5 2s, 4 2s, 3 2s, 2 2s, 1 2. No 2s left at all. So if I'm coming down, do you see a pattern that it looks like we're dividing by 2 each time? So if I divide 32 and 2, I get 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And what would happen if I said 2 divided by 2? I would end up with 1. So let's try it with the 3s. 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 3 to the 0 power. Go ahead and do the expanded form for each one of those. You can pause the video right now and do the expanded form for each one of those. It's going to be 243, 81, 27, 9, 3. So now each time that I'm dividing here, I'm dividing by 3. What do I get when I hit 3 to the 0 power? It would be 1. So for this, any value or variable raised to the 0 power is equal to 1.